Was there any ahas? Was there any, ooh, where'd that come from? Or just any overall questions from page 94? So 94, you had to find the slope first. The second one was find the slope of the y-intercept. You might have noticed that I had the y-intercept put as a point, not just as a value. When it comes down to the quiz, things you have to watch out for is, does it say what point is the y-intercept? That means it's looking for the x comma y value. If it just says what's the y-intercept, you could probably get away with either answer. That makes sense? So that was 1, 2, 3, 4. I'll take care of 5, 6, 7, 8, 9. You're trying to figure out what the linear equation that goes through. The first one, they gave you the slope and a point. The point they happened to give you was the y-intercept. The second one, they gave you the slope of the y-intercept as m and b. The third one, they gave you 2 different points and you wanted to find the equation. The 8th one, slope and a point. And that point is not the y-intercept. And then 9 is just 2 different points. And then 10 was pretty simple. You just plug it into point slope form. Is there any of those that you would like to see a little more explanation about? You have time to ask. Any on that first page that you want to take a look at? Yes, sir. Number 9? Okay. Problem number 9. So we got 1 comma negative 4, and we have 6 comma 2. So the very first thing that we've learned to do is label it x1, y1, x2, y2. We've had enough discussion saying that if this is x2, y2, and x1, y1, it's still going to be the same answer. From there, I'm going to find the slope. This is the slope equation. It's the slope equation each and every time. It's not just today. And we're going to plug our values in. So I get 2 minus negative 4 and 6 minus 1. 2 minus negative 4 is the same thing as 2 plus 4, which is 6. And then 6 minus 1 is 5. So I have a slope of 6 over 5. Do you feel okay up to this point?
Yeah.
Okay. All right. From there, we're going to plug into our point slope form, which is this. And again, I'm writing it down because you need to know it. Okay. So you're going to plug your x1, y1 in, as well as your slope. You're going to ignore the x2, y2. So I'm going to get x minus 4 is equal to the slope x minus 1. So technically we have found the equation, and I think they want us to find it in y equals mx plus b form. So that's going to be y plus 4 is equal to distribute here. Is that okay so far? The last step would be to do what to both sides? Subtract 4 from both sides. Okay? I'm going to subtract 4. I'm going to subtract 4. So let's do the arithmetic. I get negative 6 over 5 minus 4. It's the same thing as 4 over 1. Stay with me. Adding fractions. You can do it my fancy way, or you can do it the other way. You can realize that's the same thing as 20 over 5. So that's going to give me negative 26 over 5. That's my b value now. So my answer is going to be y equals 6/5 x. And I combine my like terms. Negative 6/5 minus 4 gives me negative 26 fifths. Is that all right? So you got to remember how to add fractions together to do that. Any other questions from the first page that we're not sure about? Feel okay about them? Take a second gander at it. Make sure you're okay. All right. Page 95 is up on the board. You have about 10 minutes. There's a couple of good comments. People were coming around. Oh, I have to find this first or that first. So, what stood out on that second page, that page 95, that you wanted to go over a little bit more? Yo.
Go over number 12.
12? So we have 2 points. Okay. So that's 3 negative 5 and 1 negative 4. Alright, I want to go slow through these. This is, we will do this over and over and over again. This honestly is a great thought process skill to get through. So, label x1, y1, x2, y2. This is completely the same. Thank you, Philip. Yeah, baby. That's fine. All right. All right. So finding the slopes first thing you want to do. Slope equation again. I'm writing it down because I need you to know it. Okay. If you're not writing it down, you need to start the habit of doing it. Excuse me. All right. Let's plug in what we know. So I have -4 minus -5. Then I have 1 minus 3. Does everyone feel comfortable with how you did that? Okay, negative, negative in a row, that's going to be positive, so that's going to be -4 plus 5, which is 1 over -2. Now I had this, and I had this, and I had this. They're all the same, okay, remember, with a fraction. The negative could go to the top, go to the bottom, or it could be right in the middle. They're all the exact same thing. Second step is you're going to use point slope. And again, write down point slope because I need you to know it. And with point slope, we're going to use our x1, y1. We're going to pick one of our slopes to use. They're all the same. And we're going to plug it in. So I get y minus -5 equals m, so -1/2, x minus 3. We want to solve this for y. We want to put it in slope-intercept form. So from there, we're going to distribute over the parentheses. That's y plus 5 is equal to -1/2 x plus 3/2. What's my last step? Subtract 5. So I'm going to go 3/2 minus 5. Okay, you can get a common denominator if you want, so you can go 10 over 2 is the same thing as 5. Agree? And then I'm going to subtract 3 minus 10 is -7 over 2. So that's going to go in for there. So I'm going to get y is equal to -1/2 x minus 7 over 2. And guys and girls, the only way you're going to get good at these and as good at fractions, you can't fear fraction. And I know some of you do. Just do it. You're not going to break something by trying it. Promise. I'll only make fun of you behind your back. I'll do it for now. Any other questions you came across from that second sheet? Make sure your phones are away. Any others you want to go over? Cover that second page yet. So the first one, you were given the slope at a point, which is great, and we're just plugging it into the point slope form. The second one we just did, so that's 12. 13 and 14, we were verifying if it was parallel or perpendicular. Remember, you have to solve it from y. So y equals mx plus b, you're looking at the m. If m is the same between the two, if you solve for y, that means they're parallel. Okay, so problem number 13, they're not parallel because I have one slope that's -1/2 and I have one slope that is +1/2. -1/2 is a different number than +1/2. They are not parallel. Number 14, both of them have a slope. I had to solve the second one for y, so they both have a slope of 3. That means they're parallel. 15 and 16, 15, yes, they're perpendicular. The slope of the first one is -3/5. The slope of the second one is -5/3. Those are opposite reciprocals, meaning they are opposite values from each other, and they're reciprocals. They're flip over fractions of each other. Remember, a reciprocal of a number is 1 over the number. Opposite reciprocal of the number is the negative of that number flipped over. 16, they both have a slope of 6, so they're actually parallel to each other. If they're parallel, they sure in heck can't be perpendicular to each other. Okay? So our last sheet I'm going to go ahead and post up. and take about 10. Okay, so graphing the lines, both of those were relatively okay. I couldn't really see the grid real well when I made the copies of mine. Is there any questions on 17, 18, or 19? 18?
Yeah.
Okay. 18. Number 18. Y equals 1/5 x minus 4. This is set up in slope-intercept form. So I'm going to plot -4 first. Dot. Still with me? From there, I'm going to use that. I'm going to go up 1 and over 5. Dot. Try and draw your line as straight as possible with arrows at each end. So we're okay at 17 through 19? And I probably figured that most of you probably want me to go over number 20.
No.
No.
Number 19.
19, you want it?
Oh, it's over 19.
19?
We need all.
Okay. So I think that is 1, 2, 3. And I think the other point I found was there. I think those are the 2 points that are available on there. Do you agree? So that's 0, -3, and that's 2, 1. Is that right? Okay, so I have to label one of them x1, y1, the other x2, y2. Or I could count up to it because I am at the y-intercept to find the slope right away. It's kind of whichever way you want to do it. I'll just label it x1, y1, x2, y2. So first step, find the slope. So the slope equation is 1 minus -3 over 2 minus 0. 1 minus -3 is 4. It's over 2, so I find I have a slope of 2. Still with me? And then I'm going to take my x1, y1 and plug it into my point slope form. So you get y minus -3 equals m. We just found that to be 2. X minus 0. So that's going to be y plus 3 equals 2x. 2x plus 0 if you want to do that. Subtract 3 from both sides. There it is. Okay. Another way you could have done this, if you could have recognized this to be b, you kind of counted up 2 over 1, up 2 over 1. Realize your slope is 2 over 1. And then you just plug it into y equals mx plus b that way. Same answer. So ready to go over number 20? Okay. Number 20. So you're starting out with $300. Someone gave you $300. You can go invest $300 in a bank account. And in 3 weeks, you have $375 in there. Okay? So you've put in an extra $75 over the next 3 weeks. So your x variable is weeks. Your y variable is money. You're really only using quadrant 1 in this case. So you started out at 300. Okay? And 1 week, 2 weeks, 3 weeks, 4 weeks, so on and so forth. So 3 weeks after the fact, you're up to this was at 0 weeks, 300. Okay? You go to the restroom because I'll need to. Alright, so your x variable are your weeks, your y variable is the money. So let's find the slope. x1, y1, x2, y2. Slope is y2 minus y1 over x2 minus x1. So that's 375 minus 300 over 3 minus 0. So that's 75 over 3. So I have a slope of 25. So interpret, what does the slope mean? Means every week my account has $25 extra put into it. For every $25 I put into the account, another week takes place. Okay, what is my linear equation? Well, now I have my slope. I can use y equals mx plus b, or I could have plugged into point slope. But this is my b value right here. So y equals 25x plus b, which is 300. Okay, what does the y-intercept mean? That's where I started my account. Grandma gave me a check for $300. I put it in the bank. Started my account. Now I'm going to say, all right, I'm going to put $25 a week away into the bank. Okay? Remember, X means weeks. Y means dollars. So how much money will I have after 52 weeks? So I'm going to plug 52 in for X. So I get 25 times 52 plus 300. And that comes out to $1,300. That would be in my bank account after a year's worth of money away, assuming I don't get any interest. That's a whole different concept. Feel okay about these 3 pages?
Yeah.
Okay. All right. Can I start a little bit of the next lesson? Okay. So let's talk about this. One way that you will go through life is you will see repeated patterns that take place. And you guys have noticed these patterns all the way through. And there's something called inductive reasoning, and there's something called deductive reasoning. Inductive means you're taking a whole bunch of little small steps to look at the big picture. Deductive means you're looking at the big picture and you're working backwards to make it into small little fragments. So y'all been to the mall, or y'all been to 7-Eleven, or over to the sandwich shop over there. And you'll notice on the door, there's a direction. It's usually a single word direction. It either says push or pull. Good. And if it says pull, a lot of people will push. Correct?
Yeah.
You know, it's like we're giving you a one-word command to do. And people can't even follow that. Now, I have seen people go to the mall, and you know that the mall, you're walking into the JCPenney or wherever, you have a whole panel of probably 6 doors that lead to go into the store. And they all probably say pull. Okay? Now, I have seen this, and now you'll all start seeing this as well. And if this happened to you, good for you. I have seen people push here, look into the store going, I see people in there. And then somebody comes out this door and like, oh, this door's open. Good. Good. So the pattern that they're seeing, now you guys got and girls got to realize, y'all aren't dumb. But people as a whole are dumb. And now you're thinking about going, did I see that happen at the mall once? I bet you have. If you haven't, go. It's right around Christmas time. Okay? It's going to be a lot of people. Boom. Oh, it's Monday, Mom. It's locked. Well, son, you're 38 years old. Figure out your own way to get in. Okay, Mom. I see people in there. Hey! Come here. Well, that door's open. Now, you're walking through the buffet line. You still with me in this category of events? You come to the carving station. That's where they're cutting you the nice roast beef or the turkey or whatever. And there's usually a little sign under these lights that are orange. It says caution. Now they give you 2 directives. Caution. Uh-oh. It's hot. What are you going to do? Oh, heck yeah. And you're like, yeah, it really is hot. So you're discovering things on your own. The waiter or waitress comes over to your table. You're at a restaurant with your family or your friends. The waiter or waitress has got this oven mitt that they can put into an atomic reactor. It's so thick. Watch out, your plate's hot. They set it down in front of you. Of course, they always have the corn towards you. I always have corn in back. So hot. It really is hot. You tell them around the table, they told me it was hot. This really is hot. It's like, so there's a pretty low level of things that take place. Wet paint. Look, it really is wet. No kidding, they told you. Wet cement. Oh, I'm kind of wet my initials. Tornado warning. We all run to the window to look out.
Yeah, what's it?
True.
Y'all know that, right?
What's the species?
Look out, there's a tornado outside. Oh, I want to see this.
Humans as a species aren't really that.
It's amazing we've made it this far, huh? It really is. I mean, and you know, I had many years ago, and I love these kids. They were great kids. You know, if you gave me the Three Stooges in class, these guys were the Three Stooges. Jesse, Walker, and what was Sorensen's first name? Isaac? I can't remember. Anyhow, one of my things for my classes used to be I would have hand sanitizer around the room. I mean, kind of like this, but there was more of it. And the lights are out, and I was in a darker room. And I'm sitting there teaching, and all of a sudden I see this fireball in the back of the room. The only thing that I missed amongst these rednecks was, hey, watch this. It was the only term I missed. One of the kids saturates his hand in hand sanitizer, and the other kid, hey, let me light it on fire. Hey, that'd be a good idea.
It's not that bad.
Hey, well, I understand, but I see this fireball, so what does he do? He slaps his leg. Now all the hand sanitizer's on his leg, on his jeans, and his jeans are now on fire. He's smacking it, and his friends are both sitting there. They both back up in their chairs and sitting there watching like, yeah, ride it, baby. And so he got the fire out, and I said, Mr. Sorensen, are you doing okay? Yeah. I think it's time that you get all of your books and go on down to the office. I'm in trouble for that? Well, check in with the nurse first to make sure you don't have any bad burns, but then you need to see the assistant principal. Oh, man. Poor kid. He's, Mr. Sorensen is now he's in the Army. He's a demolitions expert, so I mean, he blows stuff up. So it fit right into his whole mindset. But what cracked me up is I'm talking to his parents. His parents are like, well, you didn't tell him not to put it on his hand and light it on fire. I'm like, y'all ain't that bright, are you? I'm thinking, I didn't say that you couldn't stab your neighbor in the eye with a pencil either, and that's not really taking place. There's certain things that you kind of assume. So my whole thing is the thought process takes place on a pretty basic level. If it's pulls, you pull. That's the directions they give you. If push, you push. That's the directions they give you. One word. It says caution hot. You really shouldn't touch it, though we all do. Okay? Wet paint, of course. Caution, slippery floor. Let's see if it's slippery. Woo! It is slippery. Touch my face.
Have you ever been wall surfing?
No.
It's so much fun.
That's unbelievable. I want to see this.
Like,
You show me after class. I want to see this.
I'll show
Yeah, baby.
There's going to be a ton of people in the hall, but if I can get a pass, I'll show you.
Dude, I will move people out of the way.
Sweet.
It'll be great. I'll pull a fire alarm if we have to.
So much
I'm
fun.
kidding. I'm just kidding. All right. So what my point is you have gotten used to seeing certain small events and making a judgment call, and you've all made a judgment call. Sometimes the judgment call didn't work out real well. Sometimes the judgment call, if you do it in front of your friends, a lot of times your friends go, oh, man, you're dumb. Yeah, but it was fun. You know, there was things that we did. You know, we didn't know we weren't allowed to do it. We used to bring our bicycles and put them up on the roof of our house. And we'd ride the bicycle into the pool. Steve Zabinski went first. And he created the new rule. Make sure you keep your feet on the pedals. Actually, it came out, make sure, because count them pedals, bicycle, went, hit him in that spot. So then we start making a rule. Okay, you're gonna ride off the roof. Make sure your feet are on the pedals. Okay, good idea. Then you get the kid going real fast. He misses, a third of the pool, hits the other side. Okay, now feet on the pedals. Don't ride as fast as Shane. Okay. I mean, you hear this discovery stuff.
Trial and error.
I know, and we'll figure it out. And fortunately, what hasn't killed us has made us stronger. There's definitely been things that in my life that we made the silly choice on, but it was fun. Playing at graveyards on Halloween night. There you go. All right, so just imagine though, you had some data that was plotted, and this is called a scatter plot. The thing about a scatter plot is you can start seeing a pattern of events take place with a scatter plot. So this direction is the x-axis. This direction is called the y-axis. Agree? And a lot of times with the scatter plot, you can do something called the line of best fit that fits in there. Now, the line of best fit, as far as truly finding the perfect line of best fit, is a whole heck of a lot of work. Okay, as far as this class goes, we're going to draw a line of best fit. We're going to find 2 points that are as close to that line as possible. We're going to use those to find the line of best fit. Okay? Later on, you'll realize that what I showed you kind of is right, but there's a more sophisticated way of going through it, which you're like, dude, there's no way I'd want to do that much. Okay? So, that's basically where we're headed. So let me bring this up. Let's go. So, linear functions and inequalities, scatter plots, and lines of regression. Okay? So, problem A. Table shows the time of days of winter after December 21st, 2009. The snowpack at the tree line of a Wyoming peak. So, time and days. So, big snowstorm came through. First snowstorm of the season. Wow, 35 inches. 10 days later, there's now 52 inches as the depth. 10 more days takes place. There's now 78 inches as the depth. 40 days takes place. There's now 112. Now, I'm not adding these together. I'm just saying it went from 35 inches deep to 52 inches deep to 78 inches, so on and so forth. Okay? What is the independent variable? That's the x. And this is the time. So our x value is going to be time. What is the dependent variable? It's the snowpack. Okay? So by us doing this, we can start making some predictions on how much snow could be or how much snow was and things such as that. Okay? So 0, 10, 20, 30, 40, 50. Okay? So if I went to this, on here I could go 0, 10, 20, 30, 40, 50. And that might not be the best look at it. So I might say, well, let's space it out a little bit better. As long as we make it equal spacing, we should be good. So we go 0, 10, and we go 1, 2, 3, 1, 2, 3, 20, 1, 2, 3, 30, 1, 2, 3, 40, 1, 2, 3, 50. Okay? And that's our inches of snow. And then if I go back, I can say, okay, time in days. What did I just do? Yeah, I meant to, I labeled it the numbers right. I didn't label that's supposed to be days, right? How about that? And then this way is going to be snow. Okay? So let's think on the snow. I go 35 to 130. So should I count by ones? No. Count by fives? Maybe. I'd say maybe count by tens. Would that be okay? If I count by tens and I space it out, so it's 0, maybe 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. I might not have gotten quite enough, but I think we can make ourselves a pretty good scatter plot. So going back, 0, 35, 0, 35, Okay? 1052. 1052. 2078. 3092. And then we're going to go right off this. 40 at 112. And then 50 at 130. Does it kind of look like it would fall into the model of a straight line? I mean, and if it's not falling into an exact order, what we should do is collect more and more data points in order to get this. So this appears to have a positive correlation. Okay? A positive correlation means that if I found the slope to this line, it would be positive. That's all it means. Okay? So, what are the 2 points we'll use? We're going to get to that. We'll come back to this tomorrow. For tomorrow, what I'd like you to also work on for tomorrow, and we'll check this off, is I want you to do let's have you work on worksheet 10B, and let's do 1 and 2. You guys want to do all of them? No. Okay. Number 8. 9 through 12. Now here comes your 1 through 8 through 12. And 13 and 14. Okay? So we'll continue with scatter plot tomorrow. That worksheet is along with what we had done today. Cool? Yeah, baby.